Okay, here we're going to be looking at binary search trees in Java, and we're going to use it as an opportunity to practice designing data structures using Java classes. So I want you to start by thinking about how you would use Java to design an empty binary search tree. What would that look like? A binary search tree with just a single node in it, and then a binary search tree that had like 3 nodes in it. So I want you to pause the video and try and identify what classes you would use and what instance variables each of those classes would have. So you should pause and I'll keep going. So in our class, we're going to have a binary search tree that holds 2 things in each node. It'll hold a key and a value. So you can see here we have the BST node at the bottom. It has a key, a value, and then it's also going to have a left and right tree, and those will also be BST nodes. And similar to the list node structure, we also have a class called a binary search tree, and it's going to have a root node, which is a BST node. And we're using generics or parameterized types so that someone gets to tell us what type of object the key should be and what type of object the value should be. And remember, when we use a binary search tree, we use the key to look things up, and the value is typically what we're getting. So a typical one would be like a name and is the key, and the phone number is the value. Looking at the binary search tree constructor, you can see that just when I make an object, my this.root node is going to be set to null. So that's going to be the case of an empty binary search tree where I have no BST nodes yet. We could visualize this as a diagram. So I've got a type of object binary search tree on the left. It has an instance variable root node, and then again, BST node has key, value, left tree, and right tree. So in Racket, we had created these helper functions here, but in Java, we actually get some of this built in just by creating instance variables with these names. It gives us a lot more power in designing that data structure. Okay, next we're going to look at an example of a binary search tree, and it's going to be a little bit of silly. So my favorite number is 52 because I think it looks like E.T.'s head on like a alarm clock. So our binary search tree that we're going to use this as an example is the key is going to be someone's favorite number and the value is going to be their name. So you can ask questions like whose favorite number is 42? And obviously the answer is Prof. Dodd's. But we can't ask questions like, what is Colleen's favorite number? So again, we're using the key to search for things. And this is a silly example where the key is the favorite number. But this makes it a little easier to reason about our binary search trees because it's super easy to see if something's less than or greater than with a number. Okay, so on the bottom of the screen, I've got a main method that's adding things to our binary search tree. And as a test of your understanding of the binary search tree algorithms, I want you to try and figure out where are each of the keys 42, 18, and 52 going to end up in the memory model version of this binary search tree. Okay, so pause it here. So if we had added Dodd's first, Dodd's will be the root node, that's the 42 in Dodd's, and then we added, and it wouldn't have mattered what order we added these ones in, we get Dodd's ends up with a left tree, which is 18 in Beth, and a right subtree, which is 52 in Colleen. So here are those values filled into the memory model diagram. And an interesting thing when we're working with binary search trees is trying to come up with representations that are going to help our reasoning. So sometimes I might draw a binary search tree in this simplified version, and sometimes I might draw it focusing on the instance variables themselves. And so that's sort of a dynamic decision that you make as you're writing and debugging code. What's the diagram that's going to help me?